Enterprise software is built on absolute predictability. You input data, and you expect a specific, repeatable outcome. But large language models operate on probabilities. They are stochastic engines, generating responses that shift and vary with every prompt. A quirky, unpredictable model is manageable for a localized internal experiment, but deploying that same model across an entire organization, where it executes automated workflows or handles client data, requires rigid, deterministic reliability. Verification remains the primary barrier to deployment. Without an algorithmic way to confirm output safety, the jump to production carries a high risk of failure. Engineers can no longer rely on anecdotal vibe checks or manual prompt testing to clear a model for production. Mitigating this unpredictability demands a systemic, mathematically rigorous validation process. The central constraint in modern MLOps is the inability to quantify the abstract concept of trust into a hard, deployable metric. OpenVals is structured to address this specific verification gap through a dedicated measurement layer. OpenVals operates as an AI trust intelligence platform. It sits directly between model outputs and production environments, functioning as a definitive measurement layer. Instead of guessing if a model is reliable, the platform intercepts the outputs and translates subjective concepts like safety and hallucination risk into empirical data points. By forcing model behavior through this layer, OpenVals provides the architectural framework required to calculate a model's deployment readiness. Before you can measure trust, you have to address the logistical reality of modern enterprise AI, architectural fragmentation. Organizations rarely use a single type of model. They rely on massive large language models for complex reasoning, alongside highly efficient small language models deployed for specific, low-latency tasks. Add in corporate data security constraints, and engineers are frequently forced to deploy isolated, private AI architectures, cut off from public endpoints. A validation framework must accommodate every architectural variation simultaneously to be effective across a modern tech stack. OpenVals functions as a scale-agnostic engine. It standardizes evaluation intake across the ecosystem, routing LLMs, SLMs, and private AI models. By converting disparate outputs into identical data streams, organizations can perform direct comparisons of AI performance. Standardizing this input data is the technical prerequisite for establishing universal trust metrics. Once the data is standardized, it enters a continuous three-stage operational pipeline. The first stage evaluates the model to map baseline capabilities. Scanning raw stochastic outputs, this phase detects structural anomalies and logic inconsistencies. Outputs are then pushed into the second stage, benchmarking, cross-referenced against verified standards. Benchmarking grounds the output, establishing relative performance metrics against established datasets. The benchmark data finally reaches the third stage, validation. Here, the metrics are tested against specific enterprise parameters. Validation is distinct from benchmarking. While a benchmark measures capability, validation enforces hard safety criteria and risk thresholds to determine if a model is safe. These three stages, evaluate, benchmark, and validate, operate as an interlocking loop. Models drift over time as new data parameters are introduced. This triad runs continuously to ensure the system remains stable over its entire lifecycle. This loop provides the technical foundation for algorithmic trust. With the pipeline established, we can look at the specific threat vectors the validation stage is built to intercept. In generative models, the most critical failure mode is hallucination risk, when a model outputs completely fabricated information. OpenVals isolates hallucination risk by detecting when outputs diverge from factual grounding, diverting fabricated data from the primary stream. As anomalies accumulate, the platform generates a real-time safety score. Quantifying reliability threshold breaches maps the boundaries of safe operation. If an engineering team fails to parse out these specific, isolated metrics, logic failures can bypass human review and reach the production environment. Trust in an AI system requires the precise mathematical categorization of its exact modes of failure. The final operational step is to aggregate these isolated metrics back into a unified decision matrix. The engine takes raw performance data, cross-references with safety thresholds, and factors quantified hallucination scores. It synthesizes these variables into the ultimate output metric, deployment readiness. Calculating this specific readiness metric shifts the MLOps workflow from subjective guesswork to objective engineering. This synthesized deployment readiness score provides the technical evidence required to confirm a model's enterprise viability. Processing the data is only half the equation. We must also look at the architectural philosophy underlying the measurement platform. Utilizing a proprietary closed-source tool to measure safety creates a black box. Verifiable trust cannot be built on hidden algorithms that grade other hidden algorithms. Enterprise-grade measurement tools require absolute transparency. Engineers must be able to inspect the math that grades their models. The open-source architecture of OpenVals serves as a core functional component. It ensures the logic used to grade a model is as auditable as the model itself. AI attack vectors are constantly evolving. A transparent, community-driven approach allows for the rapid hardening of evaluation benchmarks against unforeseen edge cases. Enterprise AI safety requires a public, collaborative mechanism for continuous testing and auditing. For MLOps engineers, integrating with the OpenVals ecosystem is a straightforward process. You can access the platform via the project repository at github.com/Vishwanath Akuthota/OpenVals. Deploying the platform across diverse enterprise environments allows independent developers to stress test the engine against unique data pipelines. By identifying edge cases and reporting bugs through the repository's Issues tab, contributors accelerate the improvement of the core engine. Engineers can also submit pull requests, directly committing code to refine and update the evaluation metrics. To support the visibility of open-source validation tooling, you can star the project repository. By contributing to OpenVals, engineers are actively defining the industry standard for enterprise AI trust.